So again, denominators are the same, so I can go ahead and pull it together. But then I told you this one thing on Friday. We're subtracting these two expressions, and that second denominator is pretty big. So what should I do so I do not make the sign error? How do you properly subtract an expression? Yes, parentheses. So every time you subtract something, just put that expression in parentheses. This way the negative sign distributes and all your signs are correct. Again, a common mistake would be just to write it negative a minus 2b, so you're missing a sign as a result. You're not entirely subtracting something. So distribute negative a plus b minus a plus 2b over 6a. Is that okay? So now we just combine like terms in that numerator. So what's going to happen in that numerator? Yeah, a is canceled, and b plus 2b is 3b. Is that okay? Simplify. 3 and a 6 gives you b over 2a. So always look for the ways to simplify your final answer. How's that? Good? Okay. Let's try this one. Y over y minus 5 plus 5 over 5 minus y. So again, we kind of looked at this case on Friday. Are these two denominators the same as they appear? They're not, right? They have a different order of subtraction. And then we talked on Friday, sometimes you can change that order. If you flip around a negative sign, what will happen? If we flip 5 minus y and make it y minus 5, what will happen with that expression? Yeah, it becomes negative. Who said that? You were. You were not here on Friday. Very good. For those of you who were here on Friday, you know that? If you flip around a negative, an extra sign appears because y minus 5 is the same as negative 5 minus y. So if we do the flip, we need to remember to change the sign of the whole expression. So you see what happened? This positive turned into a negative because we flipped the order of subtraction. So this is the quickest way to get to the common denominator, right? That's pretty straightforward. If you flip around a minus, change the sign. Now denominators are the same, so I can pull them together. Y minus 5 over y minus 5. And what does that equal? 1. Because you have identical factors equals to 1. Any questions on this one? Oh, I'm not changing anything yet. I want to see if you have questions. Yeah, so this is the rule. Every time you flip the order of subtraction, the sign changes. So that's what we did. We had to change 5 minus y into y minus 5, so denominators are the same. And it made this problem a lot shorter. Otherwise, it would be a lot longer if you were finding the denominator by actually multiplying the two different denominators. Let's try something very similar. Let's do y over y plus 5 minus 5 over negative y minus 5, like that. Well, yeah, but again, first of all, it's different from what we just did, right? The problem that we just did, we have to flip the order of subtraction, right? But what can we do here? How can we turn negative y minus 5 into y plus 5? What do we have to do with that negative? Yeah, but then I'm changing the problem, right? I shouldn't be multiplying, but I can definitely factor the negative out, right? If I factor the negative, it becomes positive 1 plus 5. So this is just basic factoring. Do you agree with that? If I pull out a negative? And then, as Eric was saying, we have two negatives. Negative and a negative. What are they going to do? Positive. So this whole thing that becomes y over y plus 5 plus y and y 5. Five over y plus 5. So again, with that little factoring trick, we got the same denominators, which is the good news, because then it's just y plus 5 over y plus 5, and that equals 1. Okay, so again, if denominators are the same, life is good. And also look for this kind of for this quick little tricks to get your factors to line up. Because we shouldn't be treating these last two problems as expressions with different denominators. Because you can do little tweakage to make them the same, and then it's a whole lot easier. How's that? Yeah? Well, again, I don't know how to, it's not a rule, it's more of a logical thinking. How can you, the goal is to make them look the same. Then you're going to say, well, what is the difference between these two? What is the difference between these two denominators? Yeah. How would you describe it to a child? How these two are different? Why are they different? Yeah, so you're trying to think how to make them the same, switch it around. How do you switch it around? You change the sign. Right? This is the rule that you were kind of referring to. Now here, why are these two different? Why y plus 5 and negative y minus 5 are different? What makes them different? Well, there's more than that. There's a negative y. What else is negative? Minus 5. So you have two negatives, right? So they're different in two places. Now, again, you have to think, how do you make them the same? So one way to do is to pull out a negative. So this is just a basic factoring trick. You're just pulling out a negative sign. Okay? So you shouldn't be thinking about this as a set of rules. Just think about what you need to do in order to make those things the same. So you have options. Sometimes you can factor. Sometimes you can rotate around the negative. But if you rotate around the negative, the sign of the expression changes. No, you cannot multiply by negative 1 because that changes the problem. You can factor negative 1 out. You can multiply by positive 1, but you can never multiply by negative 1. That's illegal. It changes the problem. Okay. I didn't use any rules. I used factoring. Stop thinking about this as rules. Because you keep asking me the same question. What is the rule? No rules. Don't try to memorize this. If you're going to try to memorize this, your head will hurt, and you will probably not going to make it. Try to think about this concept. How do you make them equal? And then you operate with little tricks. There are no rules. They're tricks. Think about it that way. Okay? So, but you cannot multiply by negative 1. It's multiplying by negative 1, then might as well multiply by 0 and get it over with. Because then it just kills everything. You only have one legal step as far as multiplying is multiplying by 1. That's the only way you can do it without changing the problem. What we did here was factored. Really, what we did here, we also factored. In both cases, you factored negative 1. And you just see what happens. Okay? All right, let's try problems with different denominators. So this is a little more fun. So last time, so on Friday, we did some numerical examples. We have to find the common denominator, and we look at a pretty complex one when denominators were, I don't remember, 63 and 48. And okay, how do you find LCD for 63 and 48? So we discovered a certain algorithm for finding the least common denominator. So the first step was to factor each denominator. That's what we agreed on. Remember, we took 63 and we broke it down into product of primes, and we took 48 and we broke it down into product of primes. Remember that from Friday? Now, after you factor each denominator, you will take each distinct factor raised to the highest power that you see. This is what we did. We factored first, and we took all the highest exponents. And numerically, it looked like that. When we looked at those when we look at these two numbers, we broke 63 into 3 squared times 7. That's from Friday. Remember that? And then we broke 48 into 2 to the 4th times 3. So those were the prime factorizations of those two numbers. So then we did each factor to the highest power. So we needed 2. The highest power of 2 is 4. We needed 3. The highest power of 3 is 2. And we needed a 7. The highest power of 7 is 1. So that was the idea. You're taking all different factors to the highest powers. So we'll do the same thing. I mean, whatever this number is, that's irrelevant. We'll do the same thing with polynomials. We'll first factor them, and then we'll take all different factors to the highest powers. So it's the same technique. Okay? So then when you find the LCD, then you just have to figure out what each expression is missing. So the steps for dealing with fractions that have different denominators. So here's our algorithm for that. So when dealing with algebraic fractions that have different denominators, the first step is to factor. The second step is to find the LCD. And this is how we'll find the LCD. Just take all distinct factors to the highest power. The third step, then you're going to compare your original denominators to the least common denominator and see which terms are missing. So let's call it find the missing terms. So compare your original denominator to the LCD and see what is missing, just like you do with numerical fractions. And fourth step, multiply. Both numerator and denominator by missing terms. You do the same thing when you add, subtract numerical fractions. You find the LCD, you see what's missing, and then you multiply each top and bottom by whatever's missing. Only now it's going to be, a little more messy. Okay? I'm going to start with a simple example. So perform the operation. So what I have here is a over 4b squared plus a squared over 6b cubed. So when your denominators look like that, everything is factored. So you have to really break it down into two parts. You first look at the numericals, 4 and 6. Just think about what is the least common denominator for 4 and 6? No, no. Least common denominator. If you were to add fractions with 4 and a 6, 12, right? I'm not asking for the factor or whatever. I'm not, the smallest number that's divisible by both 4 and 6. That's 12. Now, what about b's? So I have a b. To what power do I have to raise b for the purposes of my least common denominator? Why? Well, let's go back. What does it say right here? Well, I mean, just like, just least common denominator as far as adding two fractions. Forget about the b's. What would be the common denominator for these two? 4 and a 6? No, it's not the least common. What? You got it? Yeah. So, we did 4 and 12, 4 and 6 on Friday. Now let's go back here. What is this second part state right there? Who wants to read it out loud? Read it again. Right. Okay, now let's look at this one. So which power of b do I need? B cubed, the highest power that you see. All right, 12b cubed. Because then b cubed is divisible by both b cubed and b squared, right? So again, you look at the numericals, you find the LCD for the numericals. So then you look at your factors, you always take the highest power of the common factor. So this is the least common denominator. So then we just need to find the missing terms. Now, if you want to, you can make this table. It might help. Show you. Make a little table. In the first column, I want to put the original denominators. In the middle, the LCD. And in the third one, whatever is missing. So my original denominators are 4b squared and 6b cubed. And the LCD is 12b cubed, as we just agreed. Is that okay? So then, again, you don't have to do this table, but if it helps, it helps. Just compare the original denominator with the LCD and think about what you need to multiply the original denominator to get the LCD. What is missing? How do you go from 4b squared to 12b cubed? 3b. So 3b is missing in the first one, right? That's the missing factor. What about the second one? Just 2, right? I already have a cube. So just missing a 2. So that means I need to multiply the first fraction by 3b over 3b. That's the missing term. And I need to multiply the second fraction by 2 over 2. And this will give them the same denominator. Again, you don't have to do this table. I mean, you can visually compare 4b squared with 12b cubed. And you see, all right, we're missing 3b. And you can visually compare 6b cubed with 12b cubed, and then you see missing 2. So, so the third step here, we're going to take the original problem, a over 4b squared multiplied by the missing expression, 3b over 3b plus a squared over 6b cubed multiplied by 2 over 2. And you do the same thing with the numericals anyways. You find the least common denominator, then you multiply both top and the bottom by whatever's missing. So now we have same denominators, 3ab over 12b cubed plus 2a squared over 12b cubed. So denominators and we already dealt with that. Is that okay how we got to this point? What should I always try and do when I think I'm finished? Simplify. And the way we simplify these things, we have to factor and reduce. We cannot just be crossing the b's or the 3's. We need to factor first. And the only way, is there anything that we can factor here? So in the numerator, we can pull out an a, 3b plus 2a. Did that do any good? Can I reduce anything? No. So that's my final answer. Either this or that. This is a perfectly acceptable answer. So we tried to reduce, nothing reduced. So we're done. And again, as we discussed on Friday, and as an important part, I cannot reduce by b because b is not a factor of the numerator. Just because I see a b in the numerator does not mean it's a factor of the numerator. A is a factor of the numerator because it's in both. But a is not a factor of the denominator, so I cannot reduce that. No, because of that plus. It has to be a factor in the numerator because we reduce fractions through division. So in order for me to divide both top and bottom by the same quantity, that quantity has to be a factor of top and bottom. Okay? Otherwise, and this is the silly examples I was doing on Friday, if you just start crossing out things through addition, that means you're really subtracting something from the numerator and dividing out of the denominator. So you're doing different operations. Even if you subtract from top and the bottom, that's just wrong. You cannot do that. You can only divide top and the bottom. And we only divide through, well, division. That's the only operation that divides. Right? How is that? So factor, find the LCD, multiply by whatever's missing. Again, you don't need to do that table. I don't even know why I did that. Because you can visually compare them. Should be pretty straightforward. All right. Let's do this one. X over x plus y plus x minus y. So these two denominators are different, the way they're written, right? Can I do any of those little tweakage tricks to make them the same, like we were doing in the very beginning of the lecture? Yes, but if I flip the sign, what will I get? No. No. Because in order for me to even add them, they have to be the same. They're equal. I mean, they're not the same right now, so I cannot even add it. Nothing cancels yet. Yeah, but let's go back here. Where is it? Here we go. So when we did the flip, remember the both signs changed. 5 became negative, 5 became positive, right? Both signs changed. Do I want this here? Do I want both of the signs to change? How many signs are different between this and that? Just one. Now, the examples that we did earlier, the first one, how many signs were different? Y is positive, Y is negative. 5 is negative, 5 is positive. Two signs are different. Right? How about this one? Positive, positive, negative, negative. Two signs are different. You can make that as a rule. If two signs are different, then you can do those little tweaks to make them the same. But if only one sign is different, then there's nothing you can do. Because even if you flip it, that becomes y minus x. Well, who cares? It's still different. If you factor out a negative, you'll get the same thing. So you will change both signs. So you don't want that. You want to change only one sign, and that's impossible. You cannot just change one sign and keep the other one the same. You cannot be adding 2y to a fraction. Again, when you start getting that creative, let's just multiply by 0 and we're done. I mean, you cannot just be adding 2y just randomly, right? It changes the problem, right? Because then this is what you're suggesting. Well, let's just that one and then we're good. That's what you would, is that okay with you? Your imagination just completely fails you. Because again, let's talk philosophically here. Oh, right, you have to be careful with your imagination. I mean, that's what you're suggesting, right? You should know that that's not correct, first of all, based on even like 10 minutes ago, that I'll tell you the only legal thing you can do is to multiply by 1, right? You're adding 2 to the denominator, so this equal sign is false. Right? I cannot just put an equal sign between two things that are not equal. What is 0.3? I mean, what is 1/3? It's 0.33 and so forth, right? And what is 1/5? 0.2, right? So 0.533 and goes forever. Right, that's the left-hand side if I convert it to decimals. But if I do that, that's 0.2 plus 0.2, which is 0.4. They're not the same, right? So the only legal thing you can do to a fraction, really, is to multiply by 1 without changing a fraction. This is what we did over here. This is this thing right here. This is multiplying by 1, right? 3b over 3b equals 1. This is multiplying by 1. This is the only legal things that I can really do without those little tweaks. So here, I have two different denominators, okay? Again, just assign some numerical values. Let's say 7 and a 2. If x equals 7, y equals 2, then the first denominator is 9, the second denominator is 5. 9 and a 5. Are there anything in common between these two numbers? No. What is the LCD if your denominator is 9 and 5? 45, you just multiply it, right? If you have two numerical denominators that do not have any common factors, then the LCD is the product of those two numerical denominators. So in this case, the LCD is the product of both of these denominators because they're different. They don't have anything in common. So we just took all distinct factors to the highest power that we see. Right? This is our step 2. Take each distinct factor raised to the highest power. So the highest power of x equals 1, so it's x plus y, x minus y. So this is my LCD. Yeah? Does that make sense? So without drawing the table, what is missing in the first denominator? You compare the first denominator with the LCD, what is missing? X minus y. So that means I have to multiply my first fraction by x minus y, x minus y. This will accomplish the same denominator. Right? I'm multiplying by 1. This whole expression equals 1. So that's legal. Now, if you compare the second denominator with the LCD, what is missing? X plus y. You have x minus y, so you're missing x plus y. So that tells you to multiply the second fraction by x plus y over x plus y. How's that? If I put this all together, they already have same denominators, right? The denominator is x plus y, x minus y. And in the numerator we have x times x minus y plus x times x plus y. Yeah, you want to keep your denominator factor until the very end because you hope to reduce your fraction. And you reduce your fraction when things are factored. So there's no reason for me to FOIL this denominator in order to factor it later and try to reduce it. Keep things factored, right? So denominator is factored. The numerator is not factored. Numerator is the addition of two expressions. So what I should do is to open up parentheses, combine like terms, and then hopefully reduce it, right? So this is the process. When you got to this point, we have same denominator. Now your numerator is a little messy. So open up the parentheses. Combine like terms. So you have a positive xy and a negative xy. So it gives you 2x squared in the numerator, x plus y, x minus y. And there's nothing else I can do. There are no common factors between the numerator and the denominator. Do you agree with that? Even if I FOIL this denominator out, and don't write this down, if I FOIL the denominator, which gives me x squared minus y squared using difference of squares formula, can I cross out the x squares? No, because the x squared is not a factor. The only way I can see what's a factor is through multiplication. Now it's x squared minus y squared. There's two different expressions. So I cannot be crossing out the x squares. So this is why it's good to keep everything factored till the very end. So when we got to this point, there's nothing in common. So we're done. That's the answer right here. Or that's the answer. Either way. Both acceptable. But you should always try and reduce only through canceling common factors. All right, so let's revisit this. We looked at the problem. Two different denominators cannot tweak them to make them the same. They're only different by one sign. I cannot change just one sign. I cannot change negative to positive and with some of those tricks. So if their denominators are different, those are two different factors. So I need both in my LCD. Like having a 9 and a 5, I need both. So then we multiply each fraction by what was missing in comparison to the LCD. You have x plus y, you're missing x minus y, so multiply by x minus y. You have x minus y, you're missing x plus y, so multiply by x plus y. So now the denominator is the same, you write out the numerator, open up parentheses, combine like terms, try to reduce, and you are done. Is that right? Okay, let's try this one. 3a over 4a squared minus 1 minus a plus 1 over 2a squared plus 8. So the first thing that I should do is to factor. And this is our step 1. So how can I factor that first denominator? 4a squared minus 1. Maybe. What? Well, there are no like terms to combine. First of all, what were you saying? Well, a plus 2, 2a plus 2, that's 2a plus, what was it? No, no, no. I cannot do that. Because I cannot be subtracting denominators before they're not. I'm not. Learn how to add numerical fractions. Don't do that. You cannot be adding the denominators before you know. Order of operation. What is the order of operation? Give me the order of operation. In general, for the real life, order of operation. You wake up in the morning, you brush your teeth, you take a shit, and then you go to work. Order of operation for algebraic manipulations. Give me that. Yeah, PEMDAS. What are those? Parentheses? No. Exponents? Multiplication? Well, Eric, you said PEMDAS. Everybody stop talking. You knew that. Now he's saying, I don't remember what any of that means. Just try to think. This is the abbreviation. What do you think P stands for? Parentheses. Good. E. What does E stand for? Exponents. M. Multiply. D. Divide. Addition. Subtraction. Now, addition, subtraction, multiplication, division, that order is not fixed. You can divide before you multiply. It's really multiplication and division, addition and subtraction. Okay? You with me on that? Don't write that down. You know that. Now look at this expression. It means 3a divided by something minus a plus 1 divided by something. What do you do first? Division, subtraction, division. What do you do first? Division. What do you do second? Another division, and then you do the subtraction, right? Are you with me on that? That's what you told me. Division goes before subtraction. So when you're trying to start combining the 2a squared with the 4a squared or whatever, you are violating the order of operation. You jump into subtraction before you really divide. Does that make sense? Well, no. You're not computing the exponents. You're not squaring the. I mean, a squared is a squared. You're not. If you're plugging in a number for it, then yes, you will square first. But again, let's do that. A equals 2. So we're going to plug in 3 times 2 over 4 times 2 squared minus 1 minus 2 plus 1 over 2 times 2 squared plus 2. Right? That's what you plug in 2 for A. Yeah. And then when you're trying to compute that, yes, you will first, and that's numerator, 3 times 2 equals 6. Good. In the denominator, you will square first. It's 2 squared is 4. 4 times 4, 16 minus 1, 15. Minus 2 plus 1 equals 3. Over here, 2 squared is 4, times 2 is 8, plus 2 is 10. Right? Okay, so that's when you do those exponents first. But then still, now how do you continue this? What? I have to make the numbers. And it doesn't mean that I have to subtract 3 from 6 and 10 from 15. The fractions don't work like that. We can only subtract fractions when they have same denominator. So I'm not subtracting 10 from 15 or finding anything that they have in common. My only goal is to make them equal by multiplying by whatever is missing. What is the LCD here? 30, right? Well, someone said 30. Eric, you said 30. Yeah. Yeah, you multiply 2 over 2, you multiply 3 over 3, right? And then whatever that is. 12 over 30 minus 9 over 30, you get 3 over 30. Well, first of all, you should have reduced this fraction. 6 and 15 reduced this, but that's a different story. So it's 1 over 10, right? Is that okay? Well, we should have reduced that, by the way. But anyways. So when you're dealing with fractions, no matter what, you cannot just start subtracting denominators. You have to make the denominators the same. That's your goal. And you look at them separately. You look at the two denominators separately. and you're trying to think how to make them the same. In order to make them the same, you have to factor them first. So hence my original question. How can we factor 4a squared minus 1? Two a plus 1, 2a minus 1. Difference of squares. Minus, what about the second denominator? How can you factor that one? What? Well, what is the first rule of factoring? Which is a, and what's left? 2 plus 1. Because again, if you're pulling out the a, you're dividing both terms by a. So 2a squared becomes 2a, a becomes 1. So that's the factored form. So this is why we spend some time on factoring. Before we do anything, we need to know how to factor it properly. Now, for the LCD, I'm going to take all different factors raised to the highest power. So what are my different factors that I see in that factored form over there? Do I need an a? Is a one of the factors? Yeah, it's there. It's one of the factors. Do I need a plus 1, 2a plus 1? Why not? Yeah, but it's still part of the denominator, right? So yeah, it's 2a plus 1. Do I need 2a minus 1? Sure, I see it there. This is my LCD. I need all different factors that I see piled up together. To the highest powers, there are no powers. So this will be the smallest expression that's divisible by first denominator, and that is divisible by second denominator at the same time. So that's what we do. We factor and we take all different factors, no matter how many times they appear, raised to the highest power. So now, so here's my first expression. I look at that denominator and I compare with the LCD. What is missing? What is the difference between the first denominator and the LCD? A. So that means I need to multiply the first expression by a minus a. So multiplying by what's missing. I'm trying to get them all to have the same denominator. Right? So then I compare the second denominator with the LCD. So what is missing between the second denominator and the LCD? Just visually compare the second denominator with the LCD. 2a minus 1. So we will multiply that by 2a minus 1 over 2a minus 1. So this means now these denominators that are equal. Right? They're equal denominators. These denominators are equal. I can start pulling things together. I have to be a little careful with all the distributions here. But so I'm just going to list the numerators. It's 3a times a. That's 3a squared minus the product of a plus 1 and 2a minus 1. This is what we have at this point. We still have a subtraction to take care of. Right? Can I cross out the a with the a squared? No. Because it's not factored, there's a big minus in between, so I need to get rid of that minus somehow. So the way we do what we do now, we're just going to keep that LCD the same, nothing changes there. We will open up all the parentheses in the numerator, combine like terms, try to factor again, and then see whether we can reduce that. So the way we simplify the numerator. First, we're going to FOIL. We're still going to keep everything in parentheses because of the negative sign. But if you FOIL, it's a times 2a is 2a squared. A times negative 1 is negative a. 1 times 2a is plus 2a. 1 times negative 1 is minus 1. Right? If you FOIL, you get that. And then distribute the negative, so it will change all the signs. Minus 2a squared plus a minus 2a plus 1. Again, I'm not messing with the denominator. And then combine like terms, we get a squared minus a plus 1, I think. When you combine like terms. Now, can I factor that? Can I factor that numerator? Well, a plus 1, a minus 1 gives you a squared minus 1. This is a squared minus a plus 1. How do we factor trinomials like that? You look for two numbers that multiply to positive 1 and add to negative 1. So can you think of two numbers that multiply to positive 1 and add to negative 1? Well, they'll add to negative 2. Right? So product is 1, sum is negative 1. No, it doesn't work. Right? If there was a 2 in the middle, then it would work. But so cannot factor that numerator, we're done. That's the answer done. Nothing else you can do. Because again, you're always going to try to factor and reduce. And since the numerator is not factorable, it's a prime, we're done. Yeah? You like that? Okay, good. Yeah, well.